Thanks, everybody, for joining. We're going to talk about where we are in the synthetic biology revolution and what kind of businesses are going to become huge, what it means, what the science is enabling us to do. Three amazing panelists. I'm David Rowan, a recovering journalist. I ran Wired, and now, among other things, I run a community with about 700 people in climate tech called Voyagers. And I have to give a declaration that we have a little community fund that has invested in Jacob's business. So I'm not going to favor Jacob, but just if you want to accuse me of bias, that's out there already. Jacob Nathan of Epoch Biodesign, Shara Tiku of C16 Biosciences, and Sean O'Sullivan of SOSV, which has synthetic biology companies coming through. IndieBio runs hacks, doing all sorts of investing. First of all, I want to get our terminology agreed. Sean, what do you see synthetic biology as meaning?
Yeah, well, actually, I kind of hate the term synthetic biology, so maybe you should start with someone else. But the problem with synthetic biology is that it's basically using nature to create natural products. And the whole term synthetic biology puts people off the applications that make so much sense for these areas, which are basically protein farming and cellular agriculture, two different areas of creating natural food products. And this is just in the food sector, not in biomaterials or anything else. But I think people get scared of terms that sound like they're just in the lab and they're not really just the same products that we've been eating, like milk without cows and eggs, proteins without chickens, and all these other things that synthetic biology enables. I'd rather just call them protein farming or cellular agriculture or precision fermentation, whatever you want to call it.
So some of the companies that have come through SOSV in areas like food, Perfect Day and Every and Notco and Upside and Finless Foods. And I think you're investing in, is it about 50 new climate tech related companies a year?
Yeah, well, that would be including at the seed and Series A stage. They all originally come through our programs at IndieBio or at Hacks, and then we keep investing on them until they, raise hundreds of millions of dollars. And but all of those companies are examples of great synthetic, actually some of them aren't synthetic biology companies. We've got Notco in there, which is basically just a plant-based food. There's basically, when you look at how we have to distance ourselves from animal agriculture in order to reduce our impact on global warming, there's so many good solutions. You start with the existing products people are eating today, the plant-based foods, and then you add in precision fermentation, these products that, like creating milk without cows, the proteins themselves, protein farming. And then you look at the cellular agriculture for creating meat without animals, basically meat that's grown without a brain. And those are all areas I would consider to be in the areas that a lot of people call synthetic biology.
So you didn't have a conventional journey from the science lab to putting proteins together. I mean, you've been doing all sorts of things. I think you've been investing as a super angel since the mid-90s. You created a company called MapInfo 10 years before that, which helped put maps on computers. Legend has it, you also invented the term cloud computing.
Yep.
And lived in Baghdad during the Iraq War.
Oh, yeah, you're going into a lot of history there.
So how did Sean O'Sullivan become one of the leading investors in what we call synthetic biology?
Well, I've always been an engineer, and there's this great expression, from Buckminster Fuller, which is you cannot change the future by fighting the existing reality. To really change something, you must create a new model that makes the existing model obsolete. And the obsolete model today that's killing the planet is assuming that we still have 2 billion people or less living on the planet, which we could use animal agriculture to feed the planet. But it crossed a 1 billion people 200 years ago, across 2 billion people 100 years ago in the 1920s. And in my lifetime, it's crossed 3 billion, 4 billion, 5 billion, 6 billion, and 7 billion. And if I live to a normal age, it will also cross 8 billion, 9 billion, and 10 billion people. And after 2 billion people, the planet can no longer, without causing massive climate change, support animal agriculture as a major source of protein for human beings. So I see this as an urgent problem that must be fixed, and and actually food is the lowest hanging fruit in going after and fixing that. A lot of people think with climate change, and synthetic biology is the best way of going after that. Like, if a lot of people think that with if I get an electric car, hey, I've made my contribution to the climate change. But that's like 2% of your footprint. That's 2% of your global warming footprint. It'd be 4% if the electricity was clean, but it's not. So it's 2% of your global warming footprint through your electric car. It's another 2% of your global warming footprint if you stop flying. If anyone flew here, it's actually not that big of a deal. If you give up animal-based agriculture in your food, then you have a 20% difference in the climate footprint that you have. So that's your first step. We have to actually change that. And synthetic biology is a remarkable way, and these other folks can speak to it better than I. They're the scientists and the engineers creating it.
Well, let's look at a specific use case. So Shara, at C16, you are solving a really acute environmental problem, which is trying to remove the need for palm oil to be grown on palm trees, which causes whole areas of forest to be raised. You're using precision fermentation to create equivalent palm oil. Explain, first of all, how you define synthetic biology, but then tell us a bit about what you're building.
Yeah, I think Sean articulated it very well. And I actually describe C16 as a consumer biotech company. That's the language that we use because we use biotechnology to make products for consumers. It's not pharma, it's not synthetic, it's natural. So we use the language consumer biotech, but I would agree that synthetic biology is reimagining our relationship with nature from one which has historically been extractive and forced around sort of better, cheaper, faster, and has clearly hit limits, to one which can instead be symbiotic. And it's really shifting from an industrial system which relies on animals and to some extent monoculture, agriculture, which is what we're tackling, and shifting it from sort of the animal and plant kingdoms to the fungal kingdom, and using the fungal kingdom, yeast, algae, bacteria, as modern industrial production systems. That's kind of how we view this category of synthetic biology. So we started this company, and there's a whole bunch of different types of founding stories, and you've seen a lot of them. A lot of them start with innovation in a lab. We started this company because of the problem. So about a decade ago, I was working, in a past life, I was working at Goldman Sachs. And I covered our Asia markets, and I was on a flight to Singapore. And my company sent me with a stack of N95 masks. And it was not because of COVID, obviously. It wasn't because of SARS. It was because the air quality index in Singapore was over 400. Air quality index, people are probably familiar with. When I left New York yesterday, the air quality index was about 27. 150 is considered hazardous. 300 is considered toxic. And the air quality index in Singapore when I landed was 400. They banned pregnant women from leaving the house because it was so bad. And I learned about this little thing called palm oil, which each year growers clear forest, burn the trees, and burn the carbon-rich peatland to make way for these monoculture palm plantations. And exactly as Sean said, world population is growing to 10 billion people. This problem is only getting worse. And over the last 75 years, we've already destroyed 50% of our primary forest, which are critical carbon sinks. They're biodiversity hotspots. We need them. But we're destroying them in this really extractive way. And so I met my co-founders, and we were all sort of in the Harvard and MIT ecosystem doing totally different things, not trying to start a company. But my co-founder had had basically the same experience that I had in Costa Rica. And the other thing that had happened at that time was Impossible Foods, one of the sort of early synthetic biology companies. The month that we met, Impossible Foods had launched their very first burger at a restaurant in New York at Momofuku. And so we looked at the palm oil problem. We realized that palm oil is ubiquitous. It's a $60 billion industry today. It's found in 50% of products on supermarket shelves, and everything from soaps and shampoos to lipstick and laundry detergent to Nutella and French fries. And we looked at the problem, and we realized, really interestingly, there was a clear demand statement. At that time, over 250 consumer brands had made commitments to stop using conflict palm oil, and 9 countries, all European, had made commitments against conflict palm oil as well. But they were essentially all failing because there was no viable alternative. And so we asked, my co-founder Harry is a physicist, so everything we do is rooted in first principles, and we said, what would have to be true to you if we were using biology to solve this problem? And so we looked at it with a sort of skeptic's eye, but believed that we could make something which looked and functioned like palm oil. We had $1,000 from MIT. We made about this much oil, but we got good feedback on it, and it's basically been building the company brick by brick since then.
And the process is precision fermentation. Explain what happens.
So we work with microorganisms. This is the fungal kingdom, yeast, algae, bacteria, and we make them production systems. So instead of using trees or plants to produce vegetable oils or animals to produce fat, tallow, we use these microorganisms. And so in our case, we actually found a yeast which has evolved for centuries to do exactly what we want it to do, which is make oil. There are different ways of using synthetic biology where you sort of import foreign DNA, but we actually work with evolution because nature's done a lot over hundreds, thousands of years. And we work with it, and we sort of take the evolution of nature, we combine it with this age-old artisanry of fermentation, which has been used in our food system for centuries, and we combine it with the latest and greatest tools from biotechnology, including strain engineering, so engineering the DNA of the microorganism to make more oil or make different profiles of oil, and process engineering, so changing the process conditions, adding oxygen, changing temperature, changing what we feed the microorganism, and we put it in a big steel tank like you would for beer or wine, and then we sort of spin it down and we extract an oil, and that oil looks and functions just like palm oil.
So we have to start using the language of brewing to understand what's happening here. And how far are we from being able to produce microbial palm oil at a more or less equivalent price of the palm oil that's in the supermarket shelves today?
So cost is the hardest question. And I think, as is the case with all sort of radically innovative technology, you have to have patience on cost. And with fermentation in general, the cost curve kind of looks like this. And the things that get you down the cost curve are good key performance indicators, the sort of core KPIs of your process, which you improve through lab work, scale, which you need money and a big facility to do, and the model of your production. And so I think we've done really well on our KPIs, and we're hitting commercial scale production later this year. And those two things will get us within an order of magnitude of where we need to be. And we've done that in under 4 years. So 4 years is a long time, but like palm oil is a $60 billion industry, fats and oils are on track to be a $1 trillion industry. It's gonna take time for us to be cost competitive, but if we're within an order of magnitude, there are market applications, and this is why we call it consumer biotech, because consumers care about this stuff. I'm not selling biofuel, I'm not selling industrial lubricants, I'm selling products to consumers where they want to vote with their dollars, they want to value signal. And so and by the way, there's also margin. There's room for margin in the products where we're starting. And so with that, within an order of magnitude, we can actually launch products with positive gross margins early get that revenue back into the company, and use it all to continue getting down up the scale curve and down the cost curve.
Jacob, you're at a slightly earlier stage of the journey. You only just came out of stealth with Epoch Biodesign in the last few days. This is an unusual company. Your co-founder is almost 50 years older than you, a scientific co-founder. You are using synthetic biology and computational tools to engineer enzymes. We can talk a bit about how you're doing it, but tell us how it started. You were at school.
I was at school, yeah. So, yeah, without kind of giving the full life story, I grew up as part of Gen Z. First thing on our minds all the time is we're destroying the planet and we need to do something about that. So I think I had my kind of personal epiphany moment, maybe age 13, 14, I think we all have it at some point. And I kind of had this overwhelming feeling of, okay, the planet's burning, we should put the fire out, what can I do about that? So as a teenager, you could have found me a couple of streets down protesting with a big sign, yelling outside the Houses of Parliament for climate action. I was that very annoying vegetarian friend trying to convince all my friends to join me. Didn't make a lot of friends that way. And as I got older, it sort of shifted from that. And I was given an opportunity during my final year of school to take a research class. And my teacher said, look, you've done the chemistry, done your biology, like come up with a project, research it, present your findings at the end of the year. Given my kind of environmental focus and the fact that I've been doing quite a few beach cleanups in my summers, I knew I wanted to do something in the environmental space for this project, and then kind of more specifically on plastics. This was around the time that David Attenborough's Blue Planet 2 came out. Everybody was talking about this. We were banning plastic straws for slightly less functional paper ones, and this was very, very much on the public mind. And so I dug into the plastic problem and kind of looked at fundamentally, why do we have this? And there are two sides to this equation, right? One is we make too much, right? We use it for the wrong applications. We wrap bananas in plastic wrap. That probably doesn't need to be done. But the other is that we're just really bad at recycling. Recycling is difficult. It's not really profitable. And often the bottle you put into the recycling bin does not get turned back into a bottle. It's turned into like a carpet or a piece of garden furniture, which then itself becomes waste in the future because it's not recyclable. So I kind of looked at this and said, well, if you want people to recycle, you have to make it profitable. What are ways to do that? And I thought it would be really interesting, just this concept of what if you could take plastic waste and you could turn it back into the very same chemicals that we make from fossil resource. So the idea being that actually you can make something valuable from the plastic waste, but most importantly, you could then displace fossil fuel extraction and refinement to make all the chemicals that we need to make the world go around.
So you create an incentive. Rather than recycling having a cost to a business, it could potentially earn the money because there's new materials they can sell on the
market. Exactly. And so I knew from my biology background in school that an enzyme, which is a little nano machine which enables very complex chemical reactions to happen in the cells of the microbes that you're producing to make oils, the enzymes are like the factory workers. That's what enables everything to happen. And this is the most efficient way to do a chemical reaction. So I thought, well, it'd be really great if we could find plastic-eating enzymes and convert all this plastic waste into chemicals. So kind of to cut a long story short, did a lot of reading into the literature, went out into nature, took a bunch of samples, brought them back to the lab, and the results were very promising that actually I was isolating microbes and enzymes capable of breaking down plastic waste into something. Kind of at that point, remembered I didn't have a PhD and wasn't smart enough to take that part forward. So I went online and tried to find the best person in the country to help me do that. That was a professor called Douglas Kell, who is about 50 years older than me.
And you decided not to take up your university place, so you kind of went straight to starting a business. How old are you now, Jacob?
I'm 21.
Okay, and you've just raised a fairly nice round from companies including lower carbon capital. But tell us what Epoch Biodesign is building now.
So in order to make everything we want to make with biology, we need to better understand biology. We need to be better at manipulating it for these new applications. So What we've created off of the back of Doug's academic career is a set of computational tools, so predictive modeling, protein design algorithms, and a set of physical experimental tools, new molecular biology techniques in the lab, high throughput testing, so we can look at lots of different enzymes in parallel, to engineer them to be better at what they do. And we're first applying that tool set to creating the first enzymes capable of breaking down our kind of impossible to recycle plastics at scale into the chemicals that we need to make everything from new plastics to lubricants and coatings.
What's got us here? Is it the revolution in genomics that's made it very, very cheap, relatively speaking, to sequence DNA? Is it new computational powers that are recreating our understanding of biology? What's made synthetic biology something that increasingly allows people to create products to market?
It's a combination of all those things. So certainly it's a million times cheaper to sequence a human genome than it was, in 2003 when it was first done for $4 billion. You can do it for, well, it's more than a million times cheaper. You can do it for a couple $100 these days. So that has enabled, now you still need to print the DNA, and that's a different process, that's more expensive, but you only need to basically print it once if you're going to reprogram a cell, and then you use nature to refactor, grow it and replicate it as many times as needed. So that's a major factor, but I think it's also, it's just that the need is so present that everyone is trying to solve this problem. We are facing an existential crisis that a lot of people, as Jacob talked about, a lot of people are just aware that this is something that they want to do with their lives. We're all looking to live meaningful lives of purpose, right? And there's a whole generation of people that are waking up to the forest fires and to the climate change around them and saying this isn't going to work for me. And you can certainly see it, in the science that we're not on the path that's a redeemable path right now. And the good news is the technology is coming so fast that we actually can change this. I'm not a doomsayer. I actually am incredibly encouraged by the progress that are being made across every front: biomaterials, biomass generation for carbon sequestration, refactoring, energy, creation, et cetera, like the last panel talked about. There's a lot of ways that we can do, that we can tackle this. And we just need 1,000 companies that will reinvent all the industries that exist today. There will be 1,000 new unicorns in this area of climate change, because all of those existing companies need to change how our planet is producing materials and producing food.
But it can be early stage startups that take the lead, you think? You think it can be companies that haven't raised a ton of money, haven't built factories, that can have an advantage?
It's going to take a ton of money, but it can absolutely be done by startups, because unfortunately, the entrenched people very, very, very rarely change anything. It's against their interests. It's against their capital plant. It's against all of the things that the ways that they've done business. They have to reinvent themselves. It goes back to that Buckminster Fuller quote. You can't improve things by attacking the existing reality. You have to reinvent a new model that makes the existing model obsolete. And the existing companies are not thinking of themselves as biotech companies. They're thinking of themselves as forest, energy companies, or any number of different industries of pork companies or whatever. And that's not who they will be in the future, because that way is the end of the planet. In 20 years, I think we'll still have meats that are grown by animals that people eat, but it will be a luxury market that maybe 10% of the people will be partaking in. Maybe it'll be 25 years, but it's going to happen. It's inevitable, and if it doesn't happen, then the human race is in for disaster.
And you're seeing hundreds, if not thousands, of companies pitching to be in IndieBio in your accelerator.
We get 8,000 applications a year. We select 120 companies,
Wow.
125 companies a year to back.
And what are the trends you're seeing? What's the new direction that people are going in?
Well, scaling is now the biggest problem. We were talking about how long it takes to make a protein or one of these factors. You're 4 years into it, you're still probably an order of magnitude off. That's great. That's not bad. It took Perfect Day 7 years before their products. Perfect Day is a company, the first one that makes milk without cows, and it took them 7 years to get to their first 1 million customers. So their products are now incorporated into ice creams like Brave Robot ice cream. They're incorporated into whey protein powders and all these other sort of markets where you use milk proteins, casein proteins, the whey proteins. And I remember my first company when we invented street mapping on computers. It took us 7 years, actually, same exact period of time, to get to the first 1 million people typing in an address onto a computer and seeing a street map, like how you got here today. A lot of you who didn't know, like I got here today anyway. You guys may know your way around London. But that technology of just doing that, it took 7 years, but it only took another 13 years for 1 billion people to use it. And it only took another 2 years for the second 1 billion people to use that technology, And everybody, not everybody, but more than half the people on the planet have used that technology today. I think it'll only take another 6 or 7 years before 1 billion people are using Perfect Days,
But 7 years plus 13 years, that makes it really hard for a VC firm to invest because it goes beyond.
You know what?
Time
Let your
horizons.
winners run. And a $1 trillion industry, it's worth waiting for.
Shara, how hard was it to raise? You're building something that the world hasn't seen yet. You're using science, you're taking on big incumbents, and you're a bunch of postgrads building a team.
One thing that's really interesting, so we raised our Series A in March of 2020, February of 2020. And at that point, climate tech was not a word that was being used, right? Climate tech was not a word at that time. The IPCC report had kind of just come out. People were just starting to wake up to this. And so even just 2 years ago, people are like, you're a biotech, but you don't make drugs. You're like a food tech or like an ag tech. So we couldn't be in these little buckets that VCs like verticals, right? And we couldn't fall into any of these verticals. So I think the development of climate tech and frankly, the proliferation of funds and capital focused on climate tech is a net positive for this industry. But I'm seeing it anchored at the very early stage and sort of up here at the growth stage where you get some public investors sort of moving in. There is, and again, I think this is normal for innovative businesses, there's this thing called the valley of death where you have to get to first scale and first commercialization. And I think just in all honesty, like those are big risks that a lot of investors are not comfortable taking. I think it's getting better, but it's sort of a call to action for tons more capital. And I think like even different types of capital structures. It's part VCs. VCs play a really important role, but there needs to be other type of financing that is interested in first-of-a-kind facilities. And then once the first-of-a-kind facility is built, and then scaling it. And I think we're starting to get there, but we're just starting. So it's a half answer. It's like there's a lot of growth, which is great. But we need people who are going to come in at the early stage and take on technology risk, and then market risk, and then scaling risk. And those are probably different types of investors. And I think we're still figuring out who plays in what realm and who's got that kind of risk appetite. Mm.
Jacob, you're facing technology risk, market risk, scaling risk, fundraising risk. Share honestly with us some of the stresses on the mind of an early stage founder using synthetic biology to do something which could be amazing and have massive impact, but is still some distance from coming to market.
It's day by day. But, like you've just said, these are some of the largest market opportunities that will ever exist. We're fundamentally reimagining the way we make everything, the way we feed ourselves, the clothes we wear, and everything in between. And if we don't do that, we're in for a really bad time. And so no matter those stresses, that opportunity is absolutely worth it. So there's technology risk, right? Biology is messy, it's complex. There are a lot of people who use the analogy of synthetic biology as, the 4 letters of DNA are like ones and zeros. You can write code with DNA synthesis and read code with DNA sequencing. That's great, but I think it oversimplifies the complexity of biology. And stuff doesn't always work the way you want it to. It'll work on a Monday, and then it doesn't work on the Wednesday. And so getting that to a scalable, repeatable, reliable system, which I'm sure you've gone through now, is a very difficult endeavor for sure. I think there's the question of talent, as always. It's really exciting. I think, to your comment of lots of new people getting into this space, increasingly people are going and doing their PhD with the sole goal of, I want to start a synthetic biology company, I want to go into climate tech, I want to solve these problems, but still finding those types of people who are very, very good at their science, but also willing to take on some level of entrepreneurial risk, whether that's an early stage startup or whether that's so joining an early stage startup or doing it themselves, I think is still a challenge to find those types of people.
And is this going to be, as conventional tech has been, a world with a few monopoly winners? Is there going to be, the Ginkgo type companies that dominate a sector, or do you think we can still have 1,000 flowers?
I think you can have 1,000, points of light, if you will. When you look at how much around us, we're surrounded by the petrochemical industry. It's in the carpets, it's in those plastic chairs, it's in the clothing that we're wearing. All of that needs to be reinvented because we're not going to be on petrochemicals anymore. The food that we're creating, the nitrogen, that's used in the fertilizers, we can't rely on that any longer. We have to recreate our whole chemicals industries. These are highly specialized industries that need, completely customized approaches and products at scale, and that is going to require very specialized, solutions. But they are all like, multi-billion-dollar industries that need to be replaced. It's going to take even like a pilot facility could be like $70 million, and that just to produce enough, food products that could feed maybe, hundreds of thousands of people or a million people. But we need to do this for billions of people. There need to be billions and billions of food products created every day. And you need to do this all across the world with bioreactor facilities all across the world. A large-scale bioreactor facility is $500 million, and we're just reinventing everything. It's going to take a lot of money, a lot of time to do it. There's a lot of opportunity in this space.
Well, let's try and generate some more of that money from people in the room. Now, there's a lot of people here with capital to deploy. Some of them maybe long-term capital to deploy. That's not a 7-8 year VC cycle. Let's help them out. I'm going to ask all of you as a final question. If they are assessing companies in this new magical world of synthetic biology, how can they differentiate the chances from the ones likely to make it? So I'll start with you, Sean, because you're seeing so many of them. What are the key differentiators, the key questions to ask for those that are more likely to become a winner?
Well, it's people that are tightly focused, like Shara is on an application that is about getting customers relatively quickly on board. That's a key thing. This space is not as risky as it sounds. There's so much demand and so much need for it. Our companies in this space, in climate tech, we have like a net IRR of like 66% for the climate tech companies, which is higher than many of the other areas that we invest in. So this is a good area to invest in at the venture stage. But as Shara was saying, it's also necessary for these project finance people to come in, the Wall Street style infrastructure people that are happy to get 8% returns in order to finance those $500 billion plants. And that only happens after it's proven. So we're still probably 5 years away before you start to see all the Wall Street type people and government funds going into massive scaling of these facilities. But it's remarkably productive. You can create food products that cost less and are safer for people, that are healthier for people, and that's the end game.
Sharer, help people with money to spend find the next sharers.
Business model. So we talked a lot about the technology, but this is still kind of newish, at least this iteration, and we're still figuring out business models. And most of these companies are tackling massive trillion-dollar industries, and so you've got these incumbents that are really slow, which makes B2B attractive, but really slow and hard. And then you've also got consumers. And so what companies are engaging in go-to-market strategies that are radically differentiated in a way that's compelling? I think there's a lot of cool stuff that's happening and people are testing things. So pay attention to business model and deeply resilient, committed founders, because it is long and hard and it requires a lot of money. So founders that are resilient and really, really committed to solving the problem.
And Jacob, last word. Apart from finding people who choose not to take their university place, what else should we be looking for?
I think what's exciting me most at the moment is the applications-focused businesses that are coming through. And that's because the enabling technologies have come that much further. There are regulatory and consumer tailwinds for those, but I think they're much more defensible and much more easy to differentiate than sort of say yet another kind of discovery platform. So I think companies with a very, very clear focus on the product they're going after, the market they're going after, I think for me at least are going to be some of the winners in the space.
Amazing. Lots to be optimistic about. Thank you very much, Jacob Nathan of Epoch Biodesign, Sharer Tiku of C16 Bioscience, Sean O'Sullivan of SOF SV. I'm David Rowan of Voyagers. Thank you for being part of this.
Thank you.